This video is going to demonstrate using Terraform to create a Kubernetes cluster on the KVM hypervisor. This will be a mixed operating system cluster with both Linux and Windows workers. The images were created using Packer and will be customized by Cloud Init templates as part of the Terraform deployment. We're also using HashiCorp's Vault so that the first control plane node can create a secret containing KVM tokens and certificates, which the other nodes, control plane nodes and the workers will then use to join the cluster. So we're going to start that now. We are in our Terraform directory, and in here we have definitions for our control plane nodes. We have our Linux-based workers, and then we also have a Windows worker here as well. We also are using Vault here, as noted, and what we have in Vault is our app role auth backend. So any applications or anything else that you can use Vault will use an app role to authenticate against the Vault server, at which point it can then get the secret as long as the policies and role allow it to. We also use a Vault mount of secret using the key value backend. And this means that for anything that is of the path/secret, we'll be using the key value store. And also we've got a couple of policies. One of them is only for writing, so we can only update and create, we can't read. And this one is only for reading the secret. Reason behind this is the first control plane node only needs to write the token, it doesn't need to read it at any point. And all of the other control plane nodes and workers only need to read the secret, they do not need to update it. So there's no point allowing the workers access to write or the first control plane node access to read as well. We also have a couple of roles which are attached to the policies here. One is the read role and one is the write role. And if we also look at the control plane node 01, we have a source image here, which is from the Packer images we created before. And also we have our template files, and these template files are using Cloud Config, and also they are supplied via Cloud Init to the machines. And all of our nodes have 4 gig of RAM and 2 vCPUs. So we will come out of this, and we will go and build. So if we look at a plan to see what's going to be created, there's 31 different parts to it. Vault, but mostly the libvirt provider creating KVM images. So if we do a Terraform apply on this, we should now see everything get created, and then we are now waiting for all of the machines to be created as well. So what we're going to do is ping the primary control plane node, and once that comes up, we'll log in, watch the Cloud Init output logs, and once that is completed and kubeadm is finished bringing up all of the Kubernetes containers and all of the configuration, we'll start using kubectl to watch the cluster come together. So everything's created, and now we're just waiting for everything to come up. So in this, all of the nodes, apart from one, are using Debian Buster, and one of them is using Windows 2019. So let's see if we can log into that. Looks like it is up already. I've got the right host name. And if we watch the output log, we can see it's going through the process of installing a couple of packages. Once these packages are finished, we should then be able to see this creating the cluster and then all of the Vault side to put a secret into Vault ready for the other control plane nodes and workers to join. For those curious, what we're using for a load balancer here, just to make the API highly available, we're using OpenBSD's RelayD, because I use an OpenBSD router appliance to provide DHCP, routing, DNS, and load balancing functions for my lab. We can see kubeadm has started with initializing the cluster, so I'll just wait for that to finish, and then we should be able to watch the cluster come together. We no longer need to ping. we set another session on here. We're just waiting for the admin.conf file to turn up in here. We'll go in as root on this one. We only need it to watch this. As we can see, it can take some time for all this to start. If we have a look, none of the images are in yet. Oh, some of the images have come down. So just waiting for them. And then once that's done, we can get on with watching the rest of the cluster come together. Oh, looks like we've added that into Vault. So actually, we should now be about ready to watch this. Yep, we can see now. There we go. So we've got one of the nodes. It's currently not ready, but it will be ready soon. I'll just do a watch on that to see how long it takes the other nodes to join the cluster as well. Oh, the Windows one is already joined. So now we're just waiting for the rest of the workers have joined. So it's now just up to the control plane nodes to join as well, and then we'll have a highly available control plane. We may see the watch on this timeout as the other workers come up but aren't quite ready yet to serve traffic, but the load balancer will be pointing to all of them. But the other nodes will be downloading their images, and then once they are done, they should become ready and part of the cluster. While we wait, we'll log on to one of the control plane nodes, make sure there's been no issues with creating. Yeah, so we can see here it's just taking a little bit of time. We'll have a look on the other node just in case that's encountered any issues. Looks like we've got one of them up and waiting, and potentially two of them, in fact. So that's one of the control plane nodes. Let's have a look at the other. There we go. Our entire cluster's there. So we can get rid of this. And while we are waiting, we'll go back in. And just have a watch on all. Just see what we see. Looks like we're still in the process of trying to come up, which is fine. There we are. So we can see that we have a few of the control managers waiting to come up. So I've just seen that the control plane node 03 has gone ready. Hopefully control plane node 02 will go ready soon as well. The Windows worker is going to take a lot longer to come ready for the simple reason that the kube proxy image and the kube flannel image to provide networking are much larger in size than they are on Linux, so they take a lot longer to download. So I'll be waiting anywhere upwards of around 8 to 10 minutes, maybe even longer, for this to come ready, whereas the rest of the nodes should be ready soon. So this looks like the other node has just come up. There we go. So now we have all of our control plane nodes as ready. If we just do a get pods again. Yes. As we can see here, we're now waiting for the control manager, still waiting to come up. So looks like when it says it's ready, it's still not entirely ready. But we get in there. And then, yeah, as we can see here, this has been going for 3 minutes now, and it's still container creating. The same with the Windows one for flannel. As we can see, we've not had to get involved at any point to intervene, to change anything, to fix anything. All of this should be taking care of itself, and soon the cluster should be up, ready and waiting for us to deploy applications to it. I'm concerned about that. Let's see. So that's just taking a little bit of time to sort itself out. We'll see what the controller manager is doing as well while we're waiting. So yes, it appears to think they are okay. Just do based upon cube system. We can see now, yes, they're running. So now all we are waiting for is the Windows worker. Now while we are here, we should SSH on the Windows node. And we can see there that one of the containers, it's a pause container, so it's not actually a real running container. We are waiting for the other images to finish being downloaded. Once they are downloaded, we should then be able to watch them. So while we're here, as we can see there, there's lots of HTTPS traffic, so that presumably is the image being downloaded. Let's get rid of that. Looks like one of the Windows ones has finished. That's the cube flannel. So that will be the networking side is finished. And that's taken around 7 minutes to complete. So now we're waiting for the kube proxy to complete. Once that's done, the cluster should be finished. As you can see here, this has marked the worker as ready. Technically, it would not be able to receive traffic, though, if traffic went to one of the other nodes and then needed proxying from one node to another. So say we had an IIS container running on the Windows node, but the traffic actually went to one of the Debian workers and then needed proxying over via the flannel overlay. It would get there but not be able to work because the kube proxy is not working as intended. Once that's complete, then we should have a fully working cluster. As we can see, we're 11 minutes in and we're still waiting for this to be downloaded. I'll demonstrate now how large these images are. As we can see here, the flannel container is 5 gig. If we have a look at the size of the flannel container on here, 64 meg. It's quite a big difference between the two. And as we can see, the image size here of 5 gig compared to the 64.6 meg here Vault is essentially doing the same thing, so flannel and flannel. This is why it takes longer for the Windows nodes to come up, just because it takes a lot longer to download the dependencies. This also means that if you are running Windows workers, you need to be careful with the amount of disk space you give them, because they will be much larger than those on Linux. Alternatively, if you can build your images using Windows Nano Server, they will be much smaller, around the hundreds of megabytes rather than the multiple gigabytes. So if your application can handle that and doesn't need the full Windows stack there to be able to run, then that's probably a better idea. However, at least some of the base dependencies, for example, flannel and the kubeproxy, do require at least the Windows Core OS side, if not the full Windows Server, to be able to run. And now we've finished. Taken nearly 14 minutes to download that, but we now have a fully working and functioning cluster. And if we go across to the Windows node, again, we can see that this is 5.2 gig. But we now at least have everything running. And this is it for creating the cluster.